Greetings, guys. This is Ishant Tripathi,
Hello, I am Krishna Purvar. So
and here we are showcasing our project, which is Airline Review Classification System using machine learning. And here we will show you first our code and what are the things in a code, like all the features, libraries, and encoding part, this analysis part, and
basically,
then we will show our
all the
final project.
all the performance, like what we did to
Yes,
get the project and how we
yes, and
deployed it.
then yeah, and Flask file, and then we will finally showcase the our HTML page where the project is working.
Bus,
So
bus,
let's
bus,
move on
bus,
to
bus,
the
bus, bus, bus.
and then yeah, and Flask file, and then we will finally showcase the our HTML page where the project is working.
So this is our main file where we developed our model. So these are all the libraries we use. Pandas we use for data cleaning and all. Pandas we use for scanning the data frame and the file that was provided. Then we use NumPy. NumPy we use for data cleaning, and then Matplotlib for the visualization of the data that can be seen here, and all these things. And then for the same purpose we use Cbond because it is more beautiful in the presentation. Then IMB learning for the sport, like the oversampling, to remove the oversampling of the data. Then sklearn for the training of the data, importing, pre-processing, tree, all the algorithms. For all those purposes we use the sklearn libraries. In that there was first there was a model selection for train split test. Then there was pre-processing for standard scaler where we scaled the data, and then there was the classifiers, decision tree classifier, KNN, logistic regression, Gaussian NP, random forest classifier, and SBC and XGBC. Then for that, lab, uh, for all the models, we created a matrix and compared the classification report, confusion matrix, accuracy score, and ROC and AUC, and which performed better. And then when we got our model, we made the we used the pickle library to import it into a models like that can be seen here. These are all the models, and then we use spicy for stats, then warnings, like if we got any, which luckily there weren't any. So here, after importing all the libraries, it printed the output. Then we imported our CSV file, our data, which we got from the Kaggle. And this is a link of our data which we uploaded on our GitHub. And then this was to test head. We got this data, and here were a lot of columns and approximately 23,000 reviews. Then we did overall rating, and we replaced all the null values. And then in all the data we checked the null values, and there are some. So in the airline names there was no null values. In overall rating there was no null values. In verified and unverified there were no null values. But here in type of traveler, seat type, route, date flown, seat comfort, cabin staff, food, beverages, and ground service, we had a lot of null values. So we treated them. So like I will explain a few, and rest of all we did in the same way. So type of traveler is a type of like language, basically not a numeric value. So we use the mod and replace the null values with the mod. And similarly we did with the seat type and the route, date flown, seat comfort, cabin, staff service, food and beverages, ground service. Then we again printed the head, and then we again checked for the null values, and there weren't any. And then we extracted the date and time from the date flown. From date flown we extracted month flown, year flown using regex type. And then same we did the with the origin. With the origin we got, like, from the route we got origin and destination. And then we deleted the route and date flown because we have already extracted origin and month flown, near destination. and again we printed our head. Then we got all the names of the columns, and we made a new index for the proper indexing. And then we renamed our index from that to new index, and then we printed all the airline names. Then we again printed our head. From there I would like to take Ishan to take over.
Yeah, sure. So from in this portion of code, I for like to implement the HTML page, I had to take JSON file for the airline name and the cities. So I took this, and in the next code, yeah, here we imported the label encoder for the encoding part, which is actually converting the text into numeric values. So here I took 9 label encoders for the all the 9 type of string values, which is airline name, verified, type of traveler, seat type, origin, destination, month flown, year flown, and recommended. So all of these were actually the text or string type, and we converted this to the numeric type values. Then we printed it again to see if the code worked, and yes, it did. And the next part is the analysis part, which is which is described first. It is all the mathematical statistical part, and then is the data analysis part of the data, where univariate analysis, bivariate analysis, and multivariate analysis are there. Here is the univariate. This is also comes under univariate analysis, and
Like here we can see most of the passengers just flown with the economy, and rest the
yeah,
maximum case was business class, which was almost 9%, 10%.
and here's the type of traveler and seat type bar graph. And this is the multivariate analysis, which is heat map, which is basically the correlation of all the columns. Like for example, recommended column with all the AN9 name verified and all, and then the ground service, food, beverage. Basically, it correlates between every column, like food and beverage to every other column. There's a correlation coefficient, which is between -1 to 1, -1 being the least correlated and 1 being the most correlated. So here I created two variables. Which first variable like which had the data set from airline name to ground service, and then another which only had the column name for recommended, column for recommended. And then I use this mode to prevent oversampling. And then I used a train test split to split the data uh, between X train, X test, Y train, Y test. And then I scaled the data using a standard scaler to avoid any uh, what should I say,
Like to avoid any multiplication, like
any
outliers.
outliers.
Yeah.
Yeah, exactly. I was missing the word. And then I use different type of models like decision tree and random forest, KNN,
So
all these type of classification models to see which did the best, and then printing their accuracy
so
score
basically
confusion
we
metrics.
used like here from the library we can say see we use these all these types of
Support vector XCV
classifiers.
classifier. Yeah, exactly. Classifiers type model.
So here we did all the classifications of all the medals and provided them values. So here we use decision tree classifier, then we printed then we printed the score, then same we did for random classifier.
Random forest. Yes. Logistic regression. And the out of all these, the I guess I think KNN performed the best, if I'm not
Yeah,
wrong.
here
Let's
we
see.
we did all this and then we use this we created a data frame to match all the models, and here we can see like can perform the best.
Nine with 94.3 ROCA, you said same 94.3 accuracy, KNN performed the best out of all these.
As only
and
close
we
to
choose
model
KNN,
was SVC.
support vector. Yeah, support vector was the only close one.
Yeah,
And as a KNN got the highest accuracy and ROC AUC, we chose it as a model
we
and imported the pickle file
yeah we imported the pickle
for
file,
this.
but
Yeah, this was a
this
you
was
can say the model
th-
building,
this was our whole
and
model
then
building. But then
and the,
for the betterment, when we deployed the
yeah,
final model, like this was our main file. We did all the analysis, compared all the models, and then imported the best model. So for like after creating all the models and comparing them, we did the final deployment. And for the final deployment, we created a separate folder. So we copied all the necessary code and like ran it again. And if you run this file, like if you want to build our project yourself, you can just take the data CSV file basically, and you can just run this model.py, and it will give you the required all these uh, level encoders. And then here is the our model, like this is our model KNN model 5.pkl. If you run just this file, it will give you everything. And then after the model deployment, we created our Flask file. So in the Flask file, we imported Flask, pickle, pandas, sklearn for pre-processing, obviously, because we needed the label encoding to get the data and then convert it accordingly, and then JSON and OS. So we created this file, then we loaded our model. Like here is the model, this model.pkl. So we loaded it, then we loaded all the label encoders, then we loaded all the airline names and stuff. So for this part, like encoding all the airline names, origin, destination, we did a like while we were creating the Flask for the betterment, like for the ease, uh, from the roots we
we just
use
created us, yeah,
uh,
separate file and used NLP for
yeah,
taking all the JSON file and removing the
because
like
while
the
we were
double
using
values.
it, there was very irrelevant name, like people used via, like there was route and there was destination, but they also added via this station, via this that, so we
And
removed
they
all
were
that.
yeah, repetitive names were there, so we
Yeah,
removed all that using this NLP.
NLP. So here we got this, and then we copied it, and then we pasted it. We filtered it more, and then we created a JSON file. So here is all that in this split file, and then we got these all this airline unique names. These are all the names, and then these were all the destinations. Here you can see, and same with the origin. And for the months, we hard coded it. We wrote all the names, and then and these were all the classes files. We also hard coded that, but it was okay. Same with the type of travelers, and then in a unique name, so I have already shown. And then we go to the Flask file again. Where is it? app.py. So after doing all that, we loaded the pickle, like we loaded our standard scaler, and then we defined all the routes for the like home. So we rendered a template, which we wrote. We have stored it inside the template folder in the index. So this was the HTML file, basic file. So here we wrote the head, and this was our CSS file, which is stored
Yeah,
here in the
this is all
static.
the yeah,
So then in index file, we loaded our all the names of the reviews
all the
through,
column, yeah, all the
yeah,
column names in
through this
uh,
JSON file. And same we did for
yeah.
origin, destination, month flown, overall rating. So here it will, we will get a drop down, and we can select. Same for everything. You don't have to write anything. You can just select, and it will give you the prediction here, which
Yeah,
will show you while running our model. So this was our index. Then in the app.py,
this is the Flask model.
this was the index, and then here is the prediction part. So it will take everything from
It,
these, this we have
yeah,
followed through JSON, and it will use it here, and then give
yeah,
you
this
the,
is all taking the request from the HTML page
yeah,
and getting the input, and then
then
it
it will
will
convert all these
yeah,
into the
all the
required
necessary
things
into
using the
encoding
loaded.
part. It will encode all the data, all the text data, like airline name and month flown, etc., and then it will take it as an input and then give you the final output, which is recommended or not recommended.
So I will just run the program for you. Wait a second.
Yeah.
Python 3 app.py, and here we go. So this is the path localhost where our program is running. So let's see, we choose Airbusan and the origin is, let's say, Delhi. So the origin is Delhi, and we are going to, let's say, Arizona, and the month is like right now it's December, and overall rating, I'll give the overall rating of 7. Yes, I am verified traveler. Solo leisure, yes. Economy class, no. Let's say premium economy. And then year 2023. Seat comfort, let's choose 4. Cabin and crew was okay, so let's choose 2.
3.
Food was
Okay, 2 is fine.
Food was good. Ground service was good.
It's 5 o'clock.
Not satisfied with the cabin and crew. So let's see what our model says. So it says recommended because everything else was fine except the cabin and staff. So my overall experience was good. So it will say recommended. So let's say I had a bed service. So let's do it again. Let's keep everything else same but change our overall rating to 5. Like I will say I'm a satisfied customer with the overall quality. Let's say I reached peacefully 7, but my seat comfort was not good. It was 2. And then cabin or stuff was also not good. Food and beverages was also just 2. They were okay, not good. And ground service was okay. I just made it out, but let's say I'm a satisfied customer, so I will say 7 because I reached my destination. That was my major goal. So let's say how it predicts. It says not recommended.
Not recommended.
Even if you are overall you say you are satisfied, but our model knows it was not a satisfactory flight.
Correct. Yes, exactly. And even if you put an overall rating of very nice, like if you put a 10 or 9 rating, and all the seat comfort and other things are basically low, 1 or 2, you will also get the same result as not recommended.
Let's do that too. So let's see, our overall rating is 10, but everything else is not good. So let's see, it says not recommended. So even if the customer says it's recommended, but our system knows this was not a good flight.
Yes. So this was our final result for the airline review system, and we hope that you liked it.
Yeah,
And
for the further scope, it can be like we can use NLP, which was
we can
out
use
of the
NLP for
scope
the review
for now.
Yeah.
Because
For now.
we were getting 94% accuracy, which is more than enough, we think.
Yeah, and thank you for your time.
Thanks
And
for
thank you
watching.
for watching.